Cek. suara saya? Kalau bisa Pak Isam kamu jadikan co-host juga. Biar ini bantu itu nanti. Pak Isam mungkin juga bisa share di dosen sebetulnya Pak Isam.
Ada.
Nah, di grupnya dosen.
Ada ya?
Belum ada dosen yang gabung, benar bagus sekali.
Oke.
Saya juga lupa enggak ini.
Salib dulu ya.
Nah, grupnya aja. Assalamualaikum, Dr. Hatali. Still mute your speaker.
Assalamualaikum, how are you?
I'm fine. Our Dean, Pak Dr. Solihin Asad also will join with us. Maybe you can also say good night ya in Detroit ya.
Iya.
Sorry.
So how is everybody doing? Good?
Yeah, very good.
Hello.
Yes, Dean Solihin.
Yeah.
Solihin.
How are you?
Yes.
I cannot hear you.
Can you hear me?
Yeah, now I can hear you.
Can you hear my voice?
Yes, very clear now.
Yes. Now we can hear now.
How are you, Professor Ahad Alis?
Yeah, Alhamdulillah, doing good. How about you?
It's very good, nice.
Let me see. I'm going to send a message.
2070, if I'm not mistaken, right?
Huh? Oh, Don, you are here. Okay. Yeah, I can see you, Don. Yeah.
Good morning, everyone. Thank you for joining us today's webinar. I would like to introduce myself as the Master of Ceremony for today. My name is Muhammad Al-Mazatni. I am an undergraduate in the Industrial Engineering student at Plasmar University. Before we continue to another agenda, we would like to start this webinar through praying. Praying, begin. Enough. First of all, we would like to thank the Chairman of IAM Society in Plasmar University, Dr. Muhammad Hisham STPMT, the Chairman of IAM Society in Indonesia, Prof. Dr. Wahidi Stoffel STMT, the Head of Industrial Engineering Department, Plasmar University, Mr. Dr. Eko Liquid Danu STMT, the Dean of Engineering Faculty Departments, Plasmar University, Mr. Dr. Tahan Engineer Sohin Asad, MT, and the participants of the webinar Capstone Design. So today we are presenting Capstone Design, presented by Mr. Ahad Ali, PhD, and Professor Donald M. Raymer. But before we start, let me explain our agenda for today. The first agenda is opening, the second agenda is praying, the third agenda is speeches that will be delivered by the Chairman of IAM Society, Plasmar University, and the Dean of Engineering Faculty Departments, Plasmar University, respectively. The fourth agenda is introducing the moderator. The fifth agenda is the explanation of the Capstone Design webinar material by the speaker. And the sixth agenda is the Q&A session. And the last agenda is closing.
Sorry, the voice not so clear.
Maybe you close your speaker to your mouth. Maybe please close the speaker to your mouth.
Okay. To formally begin this webinar, I would like to invite here at the stage Mr. Faisal Tariq as the President of IAM Society in Sablah Smart University to deliver the opening remarks. Please welcome Mr. Faisal Tariq.
Thank you, Mr. Ilman Zidni. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Thank you to each and every one of you for being here today at this wonderful seminar. My name is Muhammad Faisal Tariq, and as the president of the IAM student chapter in Plasmar University, it is such an honor for me to welcome all of you to this Capstone Design seminar. And before we get started, I would like to express my gratitude to Mr. Ahad Ali, PhD, and Professor Donald Reimer for taking time out of your busy schedule to attend this event and be our guest speakers. Thank you very much, and we couldn't have it done without you. In today's seminar, we will learn about Capstone Design, where students work in teams to design, build, and test prototypes about real-world open-ended problems with real-world applications. And I hope that through this seminar, we all can learn many things, especially about this Capstone Design. I would like to take too much of your time, so I will hand it back to our MC, Mr. Ilman Zidni, to proceed with the next agenda. Once again, welcome and thank you very much for attending this seminar. It is great to see many of you here. That's all from me. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Salam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for that wonderful remarks. And the second one, I would also like to invite Dr. Tahan Insinyur Solihin Asad, MD, as the Dean of Engineering Faculty Departments, Plasmar University. Please welcome Dr. Tahan Insinyur Solihin Asad, MD.
Morning, everyone. Both of all of you, Professor Ali Professor all the lecturers EM Indonesia, and the students, head of a bachelor program Universitas 11 Maret or UNS Indonesia. Speakers, Professor Ahmad and Professor Professor Ali is the director of an industrial engineering program at director of IOEM or industrial engineering and at Detroit, Michigan, and he is the director of membership we know that right now says Indonesia or in the evening. So once about this topic, capstone design. Of knowledge from several subjects and need collaboration of several knowledge that's already collected by students. Problems. The problem right now in engineering is for producing graduates who can solve a complex ladies and gentlemen, IAB organized accreditation or start accreditation is a voluntary or accreditation board for engineering education, engineering and curriculum, which is very good in planning and producing is very critical point that will be captured and information that will be collected from both speakers. I have to say thank you again. Thank you very much. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for the speech, Dr. Tehen and Senior Soyen Asad, MD. So moving to the next agenda, let me introduce our moderator for today, Ms. Elsa Aldira Hafida. Okay. Ms. Elsa Aldira Hafiza is an undergraduate industrial engineering student in 11 Maret University. She is a skill development staff of IOMS chapter 11 Maret University, a logistic and business system laboratory assistant, an event coordinator in Ruby Connect Indonesia. Elsa has been an economic delegate at the Future Leader Summit 2020, has experience as an official campus ambassador uh, in Model United Nations 2020, and joined the marketing team at the EduShip Forum MConnect Indonesia 2020. In addition, Elsa has also participated in several competitions and has become a finalist in some of those competitions. So from this point, Ms. Elsa Aldira Hafida will lead the following sections. Please welcome Ms. Elsa Aldira Hafida.
Okay, thank you so much for Allah Subhanahu wa Ta'ala, MC, and for Iron Society Chapter 11 Maret University. They give me a chance for being a moderator in this event. Thank you too for all the speakers and the participants who attend this event. So, our topic today, Capstone Design, will be presented by Professor Ahad Ali and Professor Donald M. Raymer, our special guest today. Okay, so maybe some of you are curious about who is Professor Ahad Ali and Professor Donald M. Raymer. So, I will read Professor Ahad Ali and Professor Donald M. Raymer's CV. First, for Professor Ahad Ali. So, Professor Ahad Ali is an associate professor in mechanical engineering and director of Bachelor of Science in Industrial Engineering and Master of Science in Industrial Engineering program at the Lawrence Technological University. He is the director of Smart Manufacturing and Lean System Research Group. He earned Bachelor of Science in Mechanical Engineering program from Khulna University of Engineering and Technology, Bangladesh, Masters in Systems and Engineering Management from Nanyang Technological University, Singapore, and PhD in Industrial Engineering from University of Wisconsin, Milwaukee. He has published 50 journal and 121 conference papers. He has successfully advised 7 doctoral students. He is serving as an executive director of IM Society International. Okay, second, for Professor Donald M. Raymer. So Professor Donald M. Raymer is an adjunct faculty at the A. Lane Linton Department of Mechanical Engineering in College of Engineering at Lawrence Tech in Southfield, Michigan. He coordinates the Certificate of Entrepreneurial Engineering Skills. He also holds a Bachelor of Science degree in Industrial Management from Lawrence Technological University and a Master of Arts degree in Political Science from University of Detroit. He is a certified management consultant with over 35 years of experience in working with closely held businesses. He published numerous articles on small business, entrepreneurship, and strategic thinking. He has received several awards and recognition by local, state, and federal agencies for his work in entrepreneurship and minority business development. Okay, before we continue to the main event, the presentation from Professor Ahad Ali and Professor Donald M. Raymer, I will ask some questions. For Professor Ahad Ali first, has Professor Ahad Ali attended this meeting?
Oh, yes, I'm in the meeting.
Okay, can you hear my voice, sir?
Yeah, I can hear your voice good.
Okay, how are you today? I hope you're fine.
Yeah, fine. Thank you. How about you?
I'm fine too, thank you. And then for Professor Donald M. Raymer.
Yes, I'm here. I can hear you.
Okay, how are you today, sir?
I'm excellent. Just doing very
Okay.
well. Thank you. Thank you
Thank
for
you.
asking.
So I'm really curious about the condition and situation in America, especially in this pandemic era in your area, which affects all things in country, like education system, economy, government policy, and so on. Is there any lockdown system or something similar with that, sir? Maybe for Mr. Ahadali?
Okay, let me. So can you repeat that question?
Is there any lockdown system or something similar with that in America?
Mm. So education system similar to America, that's your question?
Yeah.
Yeah, it is almost similar. So we have the, yeah, I know Indonesian program, UNS program, it is almost similar program. So you have more courses than us. So we do some kind of more applied project oriented, but almost, yeah, similar, I think. There is not much difference as curriculum wise.
Oh, okay. Okay, so because the condition in situation in America, I think is different because of this pandemic. So is there any government regulations with that pandemic era?
So mostly we are doing online teaching using Zoom, some using the Skype, some using the WebEx, or some they have the hybrid mode. Still some classes going on campus. So it's kind of various ways student learning, and dormitory sometimes close, open. It's kind of challenging, but it's still mostly going hybrid mode. And yeah, it's kind of tough for us as a teaching, and for the student also very tough for all those kind of situation, but still we are trying to maintain all those things.
Okay, so Professor Donald M. Raymer, is
Yes.
it same with Professor Ahad Ali because of this condition?
Are you asking me if the conditions are safe?
Yeah.
It depends.
Yeah, due to pandemic, the condition is what's the difference in condition? That's
Yes, you just have to be very careful wearing a mask and taking care in a classroom environment. But as Dr. Ali just mentioned, we're pretty much online in a virtual environment, and it obviously is not the same. But we are adjusting and we are learning from these new ways of delivering the content and engaging students. Um, it's it's a learning experience for all of us, faculty as well as students. However, at this time, uh, this is uh, this is the only way we can deliver our material and continue to engage our students and deliver what we say we're going to deliver in terms of the content of the course. Um, so I think as a result of all of this, I think we have many new ideas, many opportunities are being recognized, and many people are discovering skills that they never knew they had. So this is an opportunity in many regards. It depends. Do you look at the glass as being half empty or half full? So I think you think of the opportunity that's out there, and I think that collectively we'll all be stronger for having gone through this terrible well, tragedy. It's very, very sad, and we've lost many people. But we're going to come through the storm here, and we'll all be much stronger for it.
Okay, I see it. Maybe like in this country, in Indonesia especially, there's a lot of system determination from government too, but have a government policies about social distancing and so on, especially in education system. Okay, I hope the situation will be end as soon as possible, so we can back to our normal activity like before this pandemic. Amen. Okay, so without any further ado, let's get to the main event from Professor Ahadali and Professor Donald M. Raymond. So the first presentation will be presented by Professor Ahadali and the second presentation from Professor Donald M. Raymond. For Professor Ahadoli, time.
Okay, thank you. So how long is the presentation time?
How much time do we have?
How much time do you have for both presentation?
I think she's muted. Lista is muted. Everyone except us we're all muted.
So sorry,
There
sir.
she
It's
is.
45 minutes for each speaker.
45 minutes.
Yeah.
So, okay, so here and to do, I think Professor Rimar did not prepare the slides, but I have many slides. So when I'll presenting and Professor Rimar will present together. So I think that's kind of thing we can do.
Oh, okay. So if you present together, you have 1 hour.
Okay, thank you.
Okay.
Yeah, so we'll present together about 1 hour and then we want to do some more discussion, this
Okay.
kind of things. Okay, so let me share my slide. Okay, can you see it? Professor Rimar, can you see it?
Yes, absolutely. Yes.
Okay. So we have, how many people? We have more than 110 people, 111 people. I could see people from UNS, people from Mapua and Bulchan and many other universities. So first of all, I like to thank for the MC and I like to thank for the Dean of the UNS and then Department Chair of Industrial Engineering and Dr. Sutupu, IUM Indonesia President, and all other students. So today what I prepare, that's I'll go through some techniques, some tools we use for senior design project or capstone project. And I have 2 or 3 recent senior design project here in USA. So you can see how we do the senior design project here. And that would give you kind of idea. So we'll go through many tools, but you may not be using all the tools for any single senior design project. So what I put it together, you could see that outline of senior design project and to talk about research methodology. So I'll focus, see that I'll focus on the research methodology. Then we have industry sponsor project. Many IE programs, they have the industry sponsor project, most of the thing. Then I'll present one recent project here from Lawrence Tech, car holder senior design project that in the car they design. Then our industrial engineering student did the project at Synthas, track loading, unloading, ergonomic and safety issue, and then how to write a good senior design report, that kind of thing. So as you know that in senior design project, we identify most of the time here for industry, part of the industrial engineering, we identify industry projects. And where we can apply industrial engineering tools and techniques, whatever we learn in our undergraduate programs. And normally we try to see, we find a firm to identify applied projects. So where we can do various kind of things we'll talk about. Or it could be a purely innovative design project, not the industry solution, or it could be innovative project. So, and then we put all this together into the document format. So you have to write a final document, that's the senior design project, and this must be done in the team environment. So that's all we know. And when we start any senior design project, so we'll have a very simple objective. What do you want to do? And then we try to do like understand the either operations you are working on, process, or you are working on systems. And then we may do the value stream mapping or flow diagram, trying to see what is the current situation. Because any projects in industrial engineering project, either you want to do the new design or you want to do the improvement. So what we are looking for any kind of senior design project, when you understand the problem that we're trying to identify, how can we do the improvement? And when we identify, then we can identify specific objectives of the improvement, and then what will be potential saving. And again, we'll be applying all the IE tools. And if we want to do some improvements, we'll be putting some investment. How are you going to get that return on investment? That's we need to figure it out, like the business case. So here, at the beginning, I'm giving some basic example, like location analysis. Like when you're looking for, like Toyota Indonesia, they're looking for a supplier. Are they looking for supplier within Indonesia, China, Taiwan, Malaysia, India, or where they're looking for the supplier? So student can do a kind of location analysis, site selection, location, sizing of the competing alternatives, large scale process analysis. So we may do like intermodal supply chain analysis. Supply chain model could be, you can develop and then analyze it. Warehousing, then load constellation, like outbound freight and flow analysis, those kind of things you can do. And here I give other that you learn, like it could be line balancing, it could be productivity improvement, quality improvement. We'll talk a little bit more. Then you may apply Six Sigma to reduce the variation, or it could be energy related, or you could do modeling simulation of the manufacturing or assembly line. Or it could be hospital service modeling improvement, like hospital service, how much is the waiting time? That will track waiting time could be like 45 minutes, or how can we reduce to 40 minutes to 30 minutes? So that could be a project, then you analyze whole thing and how can we do that improvement? It could be airport operations. If we have the new runway planning, scheduling, those kind of things we could do. This is senior design project, and this slide I got from Professor Anjum, UAT, Pakistan, that this is kind of at the end of the 4-year or 5-year, you are putting whatever you learning into the project format. That can you really apply? Can you really apply whatever you learn in the classrooms? So like when you are going out to the industry, then you are going to solve the real life problem. So can you apply whatever tool you learn? And normally this experience you will be sharing in lifelong. Even we say that if you do a good project, that will carry for forever during your life. So then you're telling that when you go look for the job searching, this could be a good tool. Okay, how did you do a senior design project? Sometimes the student may do the startup. You may do a startup company from your senior design project. So if you pursue your graduate study, like this is called that the first final year project could be helpful for your graduate study also. So that's why in short term FYA, final year project, senior design project is kind of lifelong partners. So that's kind of thing you should put the investment. Don't look, okay, how many credits? Credit might be few, but it weight too much for your whole career. So normally, as mentioned, engineers, we solve the problems, in real life problems. And that problem coming, so we identify any problem from the engineering, design, process, system, and we want to find a solution. So engineers are problem solvers. So many times, in some part of the world, that design problem could be given by department. But in USA, normally we provide some of the project, but it could be like industry sponsored project. We'll be looking any industry, they have some problem, industry, mainly for industrial engineering I'm talking about, that our students go collect the data, analyze, and then they solve that problem. And all of our IE students, they're working with the local companies and applying IE tools for their senior design project. Even we mentioned the student may come up with innovative ideas. So student got ideas, then they can get approved from the department. Then nearby industry, they are looking to solve some problem. They're telling, okay, student can solve some problem. Or department can come up with some ideas and give it to the students. So many ways you can get the project, and it depends on the schools how they conduct the senior design project. But most of the time it could have multiple options. So when we come up with the solution, senior design solution, we'll have the multiple solutions. So normally when we come up with the solutions, then we'll have the multiple options. And you'll be giving the pros and cons for each solution. Each solution, you will give the pros and cons later, then you can do the optimization. So that's why telling the designer may evaluate the different solution, and then later they can decide, or sometimes they can combine. So if this is a pure product-oriented design, you may have the working prototype. That we'll talk about one working prototype. And we'll talk about how we solve one industry problem. You could do simulation. You could do the hardware, software, test plan, design analysis, comparative alternatives. So if you have some existing system, then you can come up with some alternatives. So in the final year project, the Capstone project, so we need to understand the stakeholder. That we will be also talking a little bit more. Then we mentioned teamwork. Then within the team, we have the leadership. They'll do the presentation skill, writing skill, and then ROI that you'll see. So in the stakeholders, so this is one example for stakeholders. This is product development. So when we do the product development, you could see some, you have the internal stakeholder within the company, like operation, marketing, sales, project management, engineering, logistics, quality, then assembly, all together you have internal. Then external, you have the suppliers, you have the partner, then you have the distributor, you have the customer. And then when we come up with any new product development, you have to consider all of the stakeholder factors. And this is for product development. Suppose you are doing for hospital, so that would be different. If you do for banking system, your stakeholder would be different. If you have a small company, local company, your stakeholder would be different. So when we do any kind of project, you need to talk to the stakeholder to get some idea. Then when you find the stakeholders, then you can rank which one that you can see external stakeholder, that customer, supplier, those are two most priority one, and then partner. And I am using this kind of document from many references. Sometimes I am putting the references here, other references I have in. So not all of the things mine, so I am picking from different resources and sharing with you so you can understand. Then if you see the internal stakeholder, you have the project management, engineering. So, and some will have the like legal, they have the less involvement in the stakeholder. So, but you have to talk to those kind of people for any kind of improvement. Then you may do, so sometimes some students, they try to do the quality function deployment. So this example is from the car battery improvement. And that's they come up with different options. You can see the customer importance giving, and they have the different option. Cheap car batteries with lifetime is still 2 years, and car battery with large capacity. So they have the various options, and then you have to develop QFD diagram, try to identify what kind of solution are you going to go. And again, some of the terminology you may not know, but I'll share that slide, then you can explore and get the more information. So this will be kind of a simple research methodology. I try to talk about the research methods. So when we want to understand, like we have the problem statement. So which problem are you going to solve? Problem statement, that means which problem are you going to solve? So that means you need to understand the problem, then come up with the objective, then we will have the multiple solutions, and then you put the alternative solution. And when you do any kind of thing, you need to do the validation, and then you have to go back at, are you receiving the objective? This is kind of a generic nature of the project, that any kind of project, a senior designer project will be similar. So here that it could be, when we analyze it, in part of the industrial engineering, we do a lot of data analysis. So when scientific behavior, if we do the data analysis, you will see what kind of behavior, investigate existing system, provide solution to a problem, explore and analyze, and create, you may create a new knowledge, those kind of things. And again, I think this is identify research topic, understand the problem, define a stakeholder, theoretical, but sometimes you can do theoretical, but mostly I do the practical one, and we identify the objective. And when we want to do the project, we have to collect some data. Sometimes for senior design project, you can get it from historical data. Like you have the demand data you are looking for, what is the automotive sale, what is the iPhone sale, what is the electronic sales in Indonesia or in Asia, then you may get historical data. Sometimes you have some public databases in the global market, in USA, North America, in Asia. So you may have like all satellite data available most of the time. You may need to do the observations, the time study, motion study, like you want to collect, go and get the data. So then you can compare historical versus the observed data. Sometimes you could have a focus group meeting. We could do the survey, Delphi study, that expert opinions. You can do interview or get the customer. So various way you can get the data. And that's you have to figure out, because you need to data, any kind of data. Even you don't have that, you can get the people opinion. Okay, give the ranking 1 to 5. Like a scale we can do, and then get different opinion that the survey. But you must have some kind of data analysis in your senior design project. Either you develop a new product, new system, new operation, that you need to do. So you can say that if we do the qualitative, you will do the survey or experiment you can do. Quantitative, you can do the survey and experiment. Qualitative, you can do the observation, focus group, and in-depth interview and other things. So that's kind of thing you can do analysis, qualitative analysis. So for literature review, you have to have a good section of the literature review if other people did the similar work or not. So that would give you some. So in your research paper or in a senior design projects, you may look for the paper from the Scoopage, Engineering Village, Science Direct, EBSCO, or you can go to a local library. And you can find those kind of thing. And if you need any help from the IUM side, we can also help you out to get some of those references from here. So now we have to talk. You can see when you have the data, then you have to do the data analysis. You can use the statistical analysis. You can use the time series, moving average, ARMA model for the forecasting. You could use the regression model. I'm mentioning here some. Then you could use the design of experiment. You could have the prediction model, or you have the artificial intelligence. Some of them may be very high level for the senior design project. You can do like, you can make the linear programming, transportation model. You can do the integer programming. You can do the theory of constraint. So here you can do like, if you can do a design of experiment, like you do that, you have the variables, and then you do the main plot and the interaction plot, you come up with the regression model. For if you see the injection molding, you have the many variables. You have the many variables. Then you have the, you can see that you have the injection is speed, pressure, temperature, all those things. Then you can come up with how to do a regression model. So if you want to do in the lab environment or the work environment, so you have the different kind of pattern or different kind of situation, how we make the quality product, quality plastic part using the injection molding. So one of our students did here, part of the, though this was the research level, like when you have the engine, and you want to make a deep drill hole, how can you do? So they did different kind of analysis and came up with what would be the regression model with the all variables. So he used the 6 variables, and based on that can come up with and then do the optimization. So what we are talking about, you have the various tools, and you'll be using some of the tools for your senior design project, for Capstone project. And you don't need to use all the tools. So you'll see for your project what would be the applicable. So you may use the Six Sigma tool. You can see Six Sigma DMAC process: define, measure, analyze, improve, and control. And each stage you have the various tools. You'll figure out what could be the tool if you are using Six Sigma. Then you can see that for Six Sigma level, you have the 3.4 defects per million. So what could be your project? Like you can understand, okay, this is the current Sigma level is 3, then you want to improve it 4 Sigma. How are you going to improve it? That could be a senior design project. So this is to do this improvement, like from 3 Sigma to go to 4 Sigma or 5 Sigma, you need to solve the problem. Automatically, you will not get the improvement. Like you have the defect. Right now, 3 Sigma, you have the, like 4 Sigma, 6,210 part defective in 1 million. And 3 Sigma, you have the 66,000. So you have to do the improvement. This improvement would not come just by doing statistical analysis. You have to do something. So here you can see problem solving approach. So you have to do like either you have to do the lean, you have to do the change the flow, and you have to do some actions. So this part is the statistics. Statistics will give you the pattern, and these will give you the solutions. So that means maybe you have to buy a new inspection system, maybe buy a new machine or the remodel the machine, and then you can see the improvement. So that means you have to do some problem solving if we see that you have to do the improvement. You may use the lean system. This is the Toyota house diagram. You may use the lean system, part of the like 7 waste reduction. You have the people, you have the Jidoka in-house quality, you have the just-in-time flow, and then you have the label balancing, establish all kind of thing. Maybe you have to do some of those, then you can see the improvement. So part of the apply for your senior design project, you'll be picking some tools from the lean applied, and then you again analyze it. So before, what was the performance, and after apply some of the tools, then what is the performance? So what we are talking about, that's if how much execution we are doing. That would be the critical. That's we use these tools. We can use this tool, plan it, but in execution, are you assuming it? That would be kind of how much improvement we are making or validation. We already mentioned that we'll be using this kind of data, primary data, secondary data for collection, and then we do the data entry, and then we do the all kind of other analysis. And then if we want to do the more artificial intelligent one, then you can use this one. What we like to see in the result and discussion, you should have some numerical results, part of your senior design, graphical results, comparison, validation. Then you may be comparing with, if we do the high level research, compare with the other published research, other people, like last year, some students, they did some senior design project and you are making the improvement. So you have to document the improvement. Or you can come up with that regression model you are talking about, time series model. Or if there is a relationship, input and output, what is the relationship? Even simple, if you want to make a good cake, you have so many variables. With so many variables, how can you make the best cake? And also we mentioned we want to do the proposed various solution option for your senior design project, that pros and cons of alternative. We do optimization, cost benefit, break-even analysis. And from the sum of the project we did, you will see And when you do any kind of improvement, you have to have that hypothesis test, that validation. You can say, oh, your system is 5% better, 10% better, quality better. But can you provide statistical validation? I'd like to see for your senior design project, you have whatever design, whatever you are doing, do you have the statistical validation or not? That we'll be looking for that statistic. As we mentioned, we could develop a simulation model and do the performance. You develop the simulation model and do the various performance. That could be a senior design project. Here we did also, some of the students did when you have the Great Lake and St. Lawrence connected with the Atlantic. So we could build a simulation model and you know, some of the tools, Arena, Pro Model, Flexium, different kind of simulation, any simulation you can use. Then you may develop the network logistics model. So you have the supplier, manufacturer, because right now in the global market, you can develop the global supply chain network. And you can see you can build a different kind of simulation for the supply chain, from the supplier to the manufacturer, distributor, you can do. In any car, it could have the like 15,000 or sometimes you can say 20,000 parts. Professor Rimmer and myself, we went to the Germany for the BMW plant. So they're mentioning their car, they had 23,000 parts in a car. So that means they have to get all the parts and then they have to manage all the reverse logistics. So some of our students also did auto supply chain like USA, Mexico, Canada. Like if you have the Toyota plant in Indonesia, and if they have the supplier, how many suppliers they are getting, if we develop that network and optimize it. So here we had the suppliers. You can see engine, then head, then they have the radiator, all those things, and they're making different model in different areas. So student did the different optimization, and they did the, even we had the like location, Venezuela is the supplier location. How is the logistic network whole will look? Think about one assembly line, you have the 23,000 parts coming from all over the world and running the assembly line and build that network. We talk about, you can say that you can do time study, motion study, line balancing, work standard, or even ISO, they have different kind of standard and the productivity, those kind of things. So you can pick for them. Then if you want to work on the human factor areas, you have to design a new curve sheet. That where and how many violations you can see. If we inspect an industry, you can identify how many OSHA violation, because they should follow OSHA or similar ISO or similar local industry standard. They should follow that all the safety guidelines. And if you inspect how many violations they're giving, doing, and then you can come up with improvement. So that could be a standalone senior design project with a different kind of, in the Mapua University in Philippines, they do many kind of work on also senior in human factors area. And those are really good. Then in the healthcare system, so you can see waiting time. You go 60 minutes. If you have waiting time 60 minutes, how to reduce to 30 minutes? Or return patient. Like they release from the hospital, research patient is 10% right now. So we want to reduce to 5%. You can do hospital inventory system. Healthcare supply chain management. So if you want to do that, the healthcare service, how to improve the supply chain. And another area now is the emerging area. You can see all the topic. That would be a big discussion. I'm not going to that direction. We can talk about Industry 4.0. All big data analysis, augmented reality, additive manufacturing, you have the Internet of Things. So all kind of things, how we can, and I is a big field that it can do a lot of integration. So here I am to give one quick example. So why that you could say that normally in Detroit area, we make one car in 1 minute. I put all the results. So if we run for 250 days, for 3 shifts, you'll be making 360,000 cars. Oh, this should be 366,000. So you run 360,000 cars from a plant. So now telling if we use IE and Lean Six Sigma, those tools, instead of 60 seconds, if we make it in 59 seconds, with 1 second improvement, you'll be making 6,000 more cars. So you'll be making 6,000 more cars, and each car making 2,000, that means you'll be making $12 million extra. So that could be like when you see the cycle time or the bottleneck operation time 60 seconds, and part of a senior design project would be like collect the data, analyze it, apply IE tool. How can you improve that cycle time? And that would improve the output, and that would be ultimately to get the value. One of my students did automotive assembly line simulations. So you can see body shop, paint shop, and the final assembly. This main 3 area: body shop, BI, body in white. You have the paint shop and the final assembly. And in one car, you have those many parts coming from all over the world. So you could have the flow diagram. I'm not going to explain. Then you might have different kind of label. You can see different kind of model. They are giving different kind of 3-lane, 4-lane, different kind of lane option that choosing for the violation. Like when you put the car into the assembly line, all parts must be there. Everything should be there. Sometimes one is missing, 2 is missing. That means how many violation you are getting. So student developed the simulation model. And based on the model, they came up with the different solutions. And you can see here how many. This is the current design. Then you have the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 different options. And you can see how many violations slowly decreasing. Starting with the 467 violation, and then you have 204. You can see how they are reducing the violation. And if there is initially they are losing 30, 2 cars, and this is losing the 14 cars. So that means they could produce more cars, and that would be for the one day, and then that could, like every day you are producing 400 cars. From the 400 cars, if we lose 32 cars, instead of we are losing 12 cars, so that would be benefit. This is one recent project here we did in our engineering technology department, and this is the current year project. So then you will see. So they are doing a product development. So they came up with the name Car and D. So this is from the Professor Ken Cook group. So I got it there. And you could see they came up with, so they have their overview, they had their organization, how they are doing it. Somebody will do the manufacturing, product R&D, and the marketing, all kind of things. And they come up with the who are they doing? This is 3 students did it this semester. So what they are doing, they want to make a cup holder. So that cup holder will have the phone, you can hold the phone, and then you have the wireless charger, all kind of things. They got some new ideas. So they're telling we had a problem that only possible solution was to create solution and solve the problem. You can see the hot problem and what their mission, what their quality, they are putting it together. Concept is a cup holder or phone holder will still allow a cup, feet, and phone to charge both wirelessly with a cord. So they want to that. This is the phone holder, this is the cup holder they want to do, and there will be the wireless charger. So first thing they did the patent search. So when you do any kind of design, USPTO, you have to search the patent. So I'll ask Professor Rimar. I mean, I'm talking too much, not giving chance Professor Rimar. Professor Rimar, you can go ahead and talk about why patent search is needed.
Yeah, one of the major skills that engineers should have is the creation of value. And in a patent, the ability to secure a patent is another indication of creating value and creating value for others, or the ability to commercialize your idea. So this is an example of a patent search. Often what this is called is determining whether or not prior art exists. Prior art would mean that there is already a patent that has been filed with the United States Patent and Trademark Office. And in the patent, you will see, this is the deck page of the patent. You will see how important it is. You'll see the claims. Most important is what are the claims that this patent has. Now, in looking at the claims, an engineer would say, well, I have a better idea. This is a good idea, but I think I can enhance or improve this product. Now, you can do that, but you have to be very careful that you do not infringe on this patent, meaning that if you infringe on the patent, that means that you would be subject to some legal action and you would not be able to use it because it was too close. This particular product, there is a similar product that is out there, and this probably is the patent on the similar product. However, it does not have all the features, does not have the functionality. So you can see what they're doing here is they are improving the functionality of the product. So in my course, Entrepreneurial Mindset for Engineers, the students are required in their final individual assignment to conduct a patent search on the idea that they have developed. So it's a very interesting process, and the process is well described on the uspto.gov site. There's also a Google search. You could do that as well. So those are my thoughts on that. One other comment I wanted to make. I think it's important to ask yourself, why are some engineers more inventive than others? Often that question is not asked, but I think you have to ask yourself that question if you are truly an engineer looking to solve a problem. Innovative thinking is very important, and understanding the science of innovation is important as well. Not here to talk about that, but I just wanted to mention it to you. Back to you, Dr. Ali.
Okay, thank you, Professor Rimmer. So they did the patent search and they found they have similar cup holder, but they want to add the features. So that's they did. Now they want to do the market research study. So how much market they can have. So they're looking how many cars in 2018, how many cars registered? 273 million cars. So in the market survey, they're telling, I can say wireless charger, telescoping, articulation, or automatic clamping. So they found that wireless charging, they would like to have, so they did some survey. So this was some survey response telling that they would prefer that wireless charging. So based on that, they came up with, you can say, would you buy this type of product? You can say 50% say yes, 50% no. And how much would you willing to pay? So they're telling that 47% telling price could be between 25 to $40, and then others than 43% say it should be 0 to 24. So at the end, you'll see what price they choose. And this is, I'm presenting that direct, they presented to Professor Ken Cook last week, and this is very recent one. So they first did the product engineering, they do the CAD model using the SolidWorks, or you can use the NX, or you can use any CAD package you develop, it come up with the product. So this is the 3D of the product. And from the 3D, they make the digital. that digital manufacturing, that 3D printing, or we call additive manufacturing. Additive manufacturing came up with, you can see this is the holder, phone holder, this is the cup holder they're putting together. And then after they make it, they're putting it in the car. So they have to show that from the 3D, they make it, this is the cup holder, this is the cup, and this is the phone. Next slide, you can see better. You can see this is that they're putting the cup here. This is the phone holder, they're putting it together, and they have to show that's okay. Now they did it. So how do they use it? So they use the injection molding, also aluminum extrusion, because they have some aluminum part to hold both cup holder and the phone holder together. So they have the aluminum extrusion and plastic injection molding together. In the real, though they did prototype, in the real life situation, how they would do it. So they are giving it so that this is aluminum extrusion and then this is the plastic injection molding machine. Now they came up with the cost. How much would be the startup cost? So this is, so they are buying injection molding machine, $12,000. They are buying the die. Then they have the extrusion. They are getting, because extrusion machine is costly, so they'll be getting from outside. And then they have the testing unit cost. So startup cost is this. Then they have the operating cost. So they have to do facility rental, insurance, marketing, staff, utility. So they have the total investment, how much would be the investment, and then all the variable cost, material cost, additive, recycle, labor, assembly, packaging, wireless charger, how much would be, then pallet cost, etc. So that the variable cost 10.8. This is 10.8 variable cost in US dollar. Fixed cost was 10.2. So they are selling. They propose that selling price will be 25. And market research based on this, they want to produce 6,000 per month. So 72,000 units per year. So break-even quantity would be 251,000, and then break-even time is 41 months. So that they figured, and you learn all those things. Part of your classes, engineering, economy, you learn all those things, and then when will be that return? Return on investment is 21%. Professor, do you want to talk a little bit about ROI?
Yeah, I just, I want to, the examples are very real to me because we also include some of the components of what you're looking at. The return on investment is extremely important. So if you looked at the overall investment, you go back a couple of slides, you will see what does it cost to launch this company. And you look at the, what was that? I was looking at the startup cost. Okay, so if you look at the startup cost and you say, how long is it going to take to get a return on this investment? And is that return on the investment an industry norm or under an industry norm? So if you're performing well, you will exceed or at least break even with an industry norm. So you could say in this type of a product, an injection molded extruded product, what would you expect would be the return on your investment? So if I was a venture capitalist, or if I was investing my own money in this, what kind of return would I expect to say, gee, this is a good opportunity. I think I'm going to put my money into this. And that number varies depending on the industry and a number of factors that can say that, well, I would expect my money back in 2 years or 3 years, whatever it may be. But I may have a shorter window and I want out of this, and I want to make sure that I'm getting an annual return. Some may say I want an annual return of 20%, 30%, depending if it's a venture capitalist or an angel investor. So return on investment is an extremely important number. There are other. This one talks about the profit, the investment, the relationship between the two, and you can build a business model. And the question is that business model sustainable? And this is what you really have to determine. So the steps that these students have gone through, they're extremely important and extremely useful in whatever they eventually end up doing, whether they work for a publicly traded company or eventually launch their own company. So I'll send it back to you.
Okay, thank you, Professor. Think about if you'd like to develop, if you are build a assembly plant, like electric vehicle assembly plant in Indonesia, to build a new plant is a huge cost. You have to buy the facility, get all the tools, machinery, people, all the things. How much is the initial investment coming and how long will it take to get that investment back? Though that is a very big scale problem, but here in the senior design project, you cannot do that big one. So that's why you may pick a small project and try to do similar approach. So that's why I'll share this one. And I'm lucky that I had this slide because I know that's one of the student taking this class. So that's, I got it from there. So, and then this is, they put the marketing ad. So marketing ad, you have this, that they have to put the marketing, how much you'll be spending for the marketing. You can see they're putting how to be the TV or radio, TV ad, Google, social media, then where will be the sales location, auto part store, Walmart, online, different way how they are selling it. That's kind of thing they're putting it together, and that is part of their question they're asking. So now this is one of our senior design, that Teresa, Jessica, and Anwar, they did a project at the Synthas for ergonomics and safety. And I'd like to ask Professor Rimmer to explain how was the project about, because Professor Rimmer, myself, we are advising those students for 1 year to do the project with the company. Professor Rimmer, go ahead.
Oh, sure. Yeah, Cintas is a publicly traded company. They're a company that started out in Cincinnati, Ohio. That's where the name Cintas came from. The company has grown over many, many years and has made acquisitions, and its primary business is uniforms, various uniforms, industrial uniforms that they rent, and they actually have a route in which this Cintas driver has a truck and goes from factory to factory and drops off uniforms and then picks them up, and then they have to be cleaned. Well, you can see this truck has returned from a route, and it has to be unloaded. And some of this clothing is soiled with oil and various other kinds of chemicals, and they have to be sorted. And the sorting process is important, but the unloading process is also important. The amount of time it takes, the sorting. So our students were kind of looking at a number of human factor aspects of this entire process. There's bending and twisting, and there are issues pertaining to fatigue. And the company had not previously studied or evaluated this entire process of unloading the trucks. So our 3 students actually had an opportunity to observe this process at a plant, at a cleaning plant, in 2 separate locations. And they were able to, by observation, video, they were actually able to study this job to determine what the standard should be. And they had statistical analysis and regression. All of the IE tools were used in this assignment. Many of them, I'm not saying all of them, many IE tools were used in this senior project, and they were presented to the management of Cintas. And they also had some issues. You can see there's a cart in this photograph. Well, the carts would move around, and there were all kinds of issues in the actual design of the cart that was used to move the soiled laundry into a position so it could be cleaned. So that was also evaluated, and also the as I mentioned, the fatigue factors were also looked at, reviewed in the human factors aspect of this project. So, Dr. Ali, I don't know if I went deep enough for you, but I think that pretty much is it.
Yeah, that's enough. Thank you. So you can see they're bringing the cloth down to the here. So what this? So they're trying to identify the unloading time of the truck. So how long it's taking? So that looking for, you can see, as Professor Rimar mentioned, they're using various tools. So unloading time looking for average maybe 15. So they did the regression model. You can see there's the line, linear line. So they came up with the regression model. Then they have this cart. They want to do ergonomic cart design. So we are coming that you'll see they come up with the design ergonomic cart. So they are making the main objective of this to improve the productivity of the synthesis. So that will help in the productivity, flow operation, loading, unloading truck, and decrease time to the whole processes. And what they did, they also did part of the little bit literature review, not that much, but little literature review, how other people did it. Then they collected this data. I mentioned that we should have the data collection, and they put that the pattern of the data, how much is the loading, unloading time. Then they also did the motion study. So this is motion study data coming, and this was the time study. So they observe and they did the time study. And part of your course, you learn all the time study, motion study, different kind of symbols. You can see SARS, graphs, release, all kind of things. So they come up with the trial 1, trial 2, trial 3. So they come up with how much would be the TMU for the motion study. And they can combine, you can see trial 4, trial 5, trial 6. So they did the motion. Then we mention any kind of project you are doing. So you'll have a flow diagram. To trying to understand move truck, then unloaded the truck, move, chart machine, one person, machine take back to the washing machine. So they do the washing, they do the dryer, finish, empty. So they put the whole process together using the flow diagram. Then they did the value stream mapping. So this is critical, that's how much is the value added and non-value added. And Professor Rimmer can talk about what is non-value added, value added, why this is important, and the ideal process and the not ideal
Yes.
process.
In any situation, any business, you have functions or tasks. Some add value and some do not add value. When we talk about something that adds value, you're actually talking about, is there something in the process that maybe we as a company should not be doing because it doesn't add value, it doesn't improve the profitability. There's no value in what we're doing. So looking at this, the stream, the value in the process, and you are analyzing each one of these processes, the question you have to ask yourself, is that a value add or is it not? If it doesn't add value, that means maybe there's a cost involved. If there's a cost involved, well, what do we need to do to it so that maybe we can add value? Maybe we can, and if not, maybe we shouldn't be doing it at all. Maybe an outside supplier or vendor should be doing it, and they could do it for a lot less than we can do it. Therefore, that could end up being a leak in our profitability of our business. So we always have to be mindful of whether a process adds value or does not add value.
So for this one, you could see here is the total time is 5 hours, but value added time is only 75 minutes.
Wow.
So here, and then after doing this study, you could see they came up with 32 minutes total time, and the value added time is, so processing time PT. So that's they're trying to figure out. They reduce the time combined. So for your senior design project, when at the beginning I mentioned, when you have the flow diagram, that means you are doing what is your, so this one is current one, as is system, current value stream mapping. So where you make the flow diagram, so you can understand what is your current, how much value added, non-value added, and then you are coming up with ideas. This is the improvement. So this will be the future value stream mapping. So for your project, you may do for any kind of project you do, so easily you can do that. One of the tools, that value stream mapping, is this value added, can you totally eliminate it or reduce it, those kind of things. Then they did the statistical analysis. You can see the histogram. They have the frequency, then they have the box plot, they did the ANOVA. So, and again, you don't need to use all the tools, but if necessary, because they want to improve their functions, that they have some safety hazards, so they want to reduce it. So you can see they did all the different data. They did the t-test. You can see they did the t-test for validation, and you can see they have the scattered plot. Then they also did the part of the simulation. They want to say when they are going through all the steps. You can see flow diagram. They have all the steps. Step 1, 2, 3, 4, 5. So they developed simulation model using the witness, and they do the performance analysis. And they also did the lean, how they want to do the 5S, and they want to use the Six Sigma area part of this thing. So one more another factor, they want to do the human factor issues or reduce the accident or while moving the card. So 3 different factors: job, individual, and organization. 3 different factors they use. So they came up with the 3 solutions: organized floor plan, foot brake, and hand brake. So we mentioned multiple solutions. And this is, they are solving the real life problem. That's the organized floor plan. You could see this is the solution number 1. They have the better floor plan. They have the foot brake, or they have the hand brake. So Professor Rimmer, you want to talk? I think this will be my kind of close to last slide for this synthesis project. Maybe
we worked very closely. The group worked very closely with the company, and we were able to get parts. We actually went out. We observed the students observed in the plant the cart and some of the issues that were very, very important to the workers. And this has really never been done before. So this solution of using the actual floor layout was very helpful to them. You can see the flow, and you can see that this cart, as I mentioned earlier, had to be redesigned. Particularly, you could see the handbrake and the foot brake, and they were used, and they were easy to use, and they were very helpful to stabilize the cart, so the cart wasn't moving around. And this actually was a value add. I mean, in terms of the process and improving the overall process and the unloading of the vehicle. Go ahead, Dr. Ali. Go ahead.
Okay, thank you, Professor. So they came up with the solution, and they came up with what would be the pros and cons, and they can give some recommendations. So you can see that I showed you 2 projects at the beginning. I gave you some of the generic example. And when you are writing your paper or report, all those things, you could see that I'm talking about the paper also or report. So you might have a summary, you have an abstract, you'll have introduction, then literature review, then we call methods, then we do the data collection, data analysis, results, discussion, recommendation, And in your school, you might have the standard guideline, how you do it, standard process, how many steps. But if you are doing design project, your report will be one kind. If you go build the logistics network, solve the problem, or you want to build a software system, that your solution would be different. Your write-up would be different. And you have to do a lot of testing, then your write-up would be different. So most of the time, I like to see if we have some data, some statistical analysis. So you should have numerical analysis, then graphical results and the validation. And make sure that you describe all figures, tables, and mention in the main body of the paper. And also you have to put all the interpretation, inferences. Do not just put, many times what happens, students, they try to put all the tables, all the charts and figures, and no discussion at all. And that's why you see, if you see American book, they have a lot of discussion, a lot of write-up. When you see other part of the world, they're writing the book, they try to all the figure and tables and equations, no write-up. So make sure when you write your senior design project, you have a good write-up. I developed this kind of senior design project rubrics. You can see for the excellent purpose, you can see introduction, problem statement, objective, literature review, and method. Those are generic stuff. So you have the poor, fair, good. That means project included all area with excellent write-up. So I am focusing on the write-up issue. Then data analysis. Your project, do you have the data analysis or not? Then improvement plan. If your project got any kind of improvement plan, or you might have the design project. So you have the new product. So if you do a new product, how good is your new product? So that's you need to validate it. The results and discussion, you put the result and discussion, you have this, and then make sure you don't have the typos, grammar, errors, all kind of thing. And that's why you should have a good write-up. And that could be when you go for job interview, you can give a whole project report, and they could see how good is your report, and that could be selling point for you. Professor, do you like to add? I think I have 2 more slides only. So.
Yes, I can't overemphasize the importance of the senior design project and how it will add value to your future. It really is a skill. The fact that you can communicate in a document, that you have good writing skills, you're using the appropriate words to communicate with in this report that you're writing, and also that you've done the research, you've used the tools. So that really is a link between theory and practice. I can only say that this is really a very important step in your journey, and this can bode well for you as you move into to your chosen field of industrial and systems engineering.
So you can also talk about sustainability in your project. That's what about the sustainability, recycle, reverse logistic, and Professor Rimar does a lot of problem-based learning, maybe we can talk a little bit about that one so they would know a little bit.
Yeah, one of the projects that we work on in my class, Entrepreneurial Mindset for Engineers, we actually help the engineer develop the right side of their brain and help them think like entrepreneurs. So there is a project that we have developed over a period of years, and it is called Tires, Tires, Tires Everywhere, What Shall We Do? And it really focuses on the sustainability of the tire at the end of life. And the project actually develops a plant to recycle tires in a country that the students have selected. They can select from 15 countries. And what we're trying to do is a U.S. company is trying to establish a plant in another country. It could be Indonesia. So the student has to evaluate the opportunity for crumb rubber in Indonesia and determine whether or not there is a market or not. what will it cost to produce the product, what kinds of products they're going to manufacture, and it ends up as a business case. However, many of the engineering tools are used in the development because there is a section in which there is a plant layout. All of that is determined. And they have to analyze the manufacturing process and determine which of two processes they're going to use to break down the tire, remove the steel and the fabric from this process. So it's a very interesting case. We've been doing it for a number of years, and the students seem to enjoy it. And it also is an opportunity to engage in looking at other countries, their culture, their monetary system, economics, and it works very well. We have a number of examples in which students have actually had an opportunity to talk with companies like Michelin, Toyo, Firestone, various companies that actually are manufacture tires. There's quite a bit of regulation, government regulation involved in this process as well. So I think this is another opportunity for students to link theory and practice and also focus on sustainability. The recycling of tires is a massive problem globally.
Okay, thank you, Professor Rimar. So we are almost close, and to bring one thing you can see for innovation, me and Professor Rimar want to share it little for innovation. So if we see the taxi business in USA, it was very good taxi business. Now when Uber came, then taxi business is gone. Professor Rimar and myself, we went to that San Francisco, and in the airport, even we could not find almost no taxi because everybody using the Uber. We could not set up the phone. So that's when new technology is coming. When you could see the BlackBerry, when iPhone came with the touch screen, so BlackBerry, they had market 90%. Now they have almost none. And when iPhone took the market because of the touch screen situation. So how this innovation will change? So student, like when you have the book Borders is gone because of the Amazon other thing. Now Professor Rimar can talk about the film.
Yeah, probably one of the most well-known companies in the world was Kodak. Kodak, located in New York, in Rochester. Kodak was a company that was completely dependent on the processing, the sale, and the processing of film. So I guess the breakthrough, the innovative breakthrough, came about by a couple of engineers discovering that there was a process that could be used in which film was no longer necessary. 1977, Kodak actually developed, these two engineers, a digital chip. Can you believe that? 1977. Unfortunately, Kodak did not have a culture that embraced innovative thinking. They ignored the engineers and they went about their business. Also remember that Kodak, or you may not be aware of this, acquired a company called Eastman. Eastman was a chemical company, and you needed chemicals to process or develop the film. So it was kind of a nightmare because the film business was probably, I would say, 90% of their revenue. So when these two engineers walked into their supervisor's office and said, "We found something, we have an idea here that will completely eliminate film." Well, you can imagine what the supervisor said to these two engineers. They thought they were actually crazy. They were going to ruin their business. So again, Kodak was left in the dark, and eventually the company just declared bankruptcy. This basically focuses on how important it is for innovative thinkers, or what I like to call entrepreneurial engineers, to actually be welcomed in a company's culture. It's a very sad story about Kodak, because they were an American icon that had a global footprint, and unfortunately they're not around anymore. In my class, I bring a old Kodak Brownie Hawkeye camera in. I actually show the students a negative. What does a negative look like? What does that mean? Many students have never seen that before. So when we talk about how systems evolve, this is really part of the science of innovation. And truly innovative engineers will embrace innovative thinking and address this in a way that gets the attention of the management. But if the company does not have a culture that embraces this type of thinking, unfortunately, ideas like the digital photography will go no place. And of course, there were others that embraced this rather quickly and moved along. And of course, we then had cameras in our phones, and the digital chip grew and grew.
Okay, thank you, Professor Reimer. So why we are bringing this part of senior design project? When industrial engineering, they are doing their senior design project, they are not just doing just for design, they are looking for their market, what's going on. So if you put so much, but there is no market, so you have to do the market study. So what's going on? So in industrial engineer, they will be looking for more bigger picture, what's coming, and coordinate with other engineers to improve the whole enterprises, the company level. So think about, you are managing the company and how you can manage the whole company with the productivity increase, quality increase. So here I like to just mention that, give the final task, and then we'll conclude our presentation and open for the questions, and to make open one more. So when you do your senior design project, so either you are improving quality, you are reducing cost, and all you will be using different, then improving the service level improvement, like hospital, all the service industry. You can come up with the new tools, new design, or new parts that will be economically improve safety. And in the industrial environment, you have the less accident. So if you have the productivity improvement, so you have to come up with some problem that's what would be your main contribution for your senior design project. That would be part of the thing. And then so you put, okay, this is the thing, I want to improve the productivity 5%, quality 2%, or 1 sigma level improvement, or you want to reduce the cost, or you want to reduce the number of accidents happening. All kind of things. So you have to come up with the problem, and then make sure at the beginning you make the problem that you're trying to solve. You have your objectives. At the beginning, you put your objective. At the end, achieve your objectives. So you have to showcase with the documentation, whatever you put, that you are achieving the objective. So that's your concluding. So whatever, like you're coming to school to get a bachelor degree, after 4 or 5 years, if you don't get bachelor degree, that means you did not fulfill your objective. Same thing for senior design project, you have a specific objectives. And after going through collecting data, analyze, solution, alternative approaches, business case, ROI, all kind of things, that means whatever your objective, you are fulfilling the objective, that you have to make sure that you are doing it. So for this time, that we can mention that we talk at the beginning a little bit what is senior design project. Then I talk a little bit about the design methodology. We talk about industry responsive project. And all IE projects is very good if you go for service industry, hospital, healthcare, then manufacturing is one, logistics, supply chain. And if you can solve real life problem, then you can cut data easily. And then I presented our engineering technology department CAF folder project for this semester. Last semester, our student did the synthesis project. And we talk about how do you write the whole paper with the all kind of guidelines given. So that's all. I put it together and to just show you briefly. So we have our industrial engineering lab here at Lawrence Tech. And your students, some of your students, 2 years visited us from UNS. And then this is part of the, we have the assembly line here, and we have our sponsors for the company Siemens, Electromatic, Foresia, FCA, SAS, Synthas, Value, and Asram. And we do our industry visit. You could see we do our senior design project in the industry, that kind of thing. And we have upcoming conferences. You can put your senior design, if you have undergraduate paper or graduate paper, you can share with us. And that's, I put it together. And again, sorry, we didn't have the slides for the Professor Reamer, but we try to jointly present this. And if you have any question, you can send me email, and Professor Reamer email is DREMER@ltu.edu. You can email us. So that's all we have right now. So now we are open for question. Professor Rima, do you like to add anything else for the?
No, just thank you very much. I'm just delighted that I was here, and I've always enjoyed the students from Indonesia. I enjoy your country. It's beautiful. And what is the most beautiful are the people of your country. They're very welcoming. I also enjoy the food and the hospitality. So thank you for inviting us. We appreciate the opportunity to share our slides and the information that we provided, and we welcome the opportunity to have any questions that you may want to ask.
Again, thank you. We have many participants from Philippines, from the Mapua, then Bulchan University and other university, and many other schools, not just UNS, many other schools participating. And again, everybody, mainly for the faculty from the UNS, and then Dr. Sutupu and others, and the MC, you can have back, so you can continue. Yeah, thank you.
Okay, thank you so much for Professor Ahadali and Professor Donald Emeringer for that amazing presentation. I hope the presentation from Professor Ahadali and Professor Donald Emeringer can help us to add further insights. So I see that Capstone Design is a project where students work in teams to design, build, and test prototypes of real-world, open-end problems with real-world applications. There are some steps to do, like step problem, investigate alternative solutions, model the systems, integrate, launch the systems, assess performance, and finally re-evaluate. So now we go to the Q&A session. Okay, if you have a question, you can write it in the chat box, or you can ask via open mic by raise hand first. We have 15 minutes for this session. I will wait for the first questioner. Okay, so we have a first question from Fitra Lestari from UIN Sultan Syarif Kasim Riau. For Fitra Lestari, you can open your microphone for asking.
Okay, thank you, Ms. Lisa. Thank you very much for Prof. Ali and Prof. Don. The first I want to introduce, I am head of Department Industrial Engineering in Islamic University in Riau. So I hear your presentation from the start until now. So interesting for me. I have some question I want to discuss. The first questions, the basic question, I think, what the difference between senior capstone designs with the final project? Because in our curriculum have also final project. So what the different things between two subjects? This is the first question. And the second question, I interest about the senior capstone design because it can involve industrial partnership. So is it possible for us to run the competition senior capstone design between university in Indonesia, because I'm also a representative from the EOM Indonesia, so we want to propose this event, the competition in Indonesia. This is my question. Thank you very much.
Okay, let me. So yeah, that is quite interesting. So you have the Capstone Design and final year project different. I thought the same one. So we think in USA, Capstone Design senior project, the same thing. So we don't have the different ones. So they do 2 semesters and they do that. Sometimes we call final year project, mainly called in Middle East Asia region, but we call senior design project. But that is also Capstone Design project. And second thing is, yeah, we are interested to have that Capstone Design competition within US, within Indonesia, or even we could make that like a South Asia competitions of Philippines, then Taiwan, Malaysia, other students can join. Professor Rima, do you want to say anything here?
No, I think that says it all. I think that we would very much like to have the competitions as you described, and we will assist in any way possible that we can to and to make this a reality. But I think you explained it well, Dr. Ali.
Yeah, I need to understand more about what is the difference in capstone and the senior final year project. But here we treat them both same. That's why sometimes I take final year project or the capstone project as the same way, not just a different way. But I need to understand a little bit more how you do in Indonesia.
Okay, thank you for Oli. And is it possible for me to continue my question? Is it possible? Is this Lisa? Just a
Yeah,
little
it's
part.
possible.
Little part. Okay. Please share for us, Prof. Ali and Prof. Don, about your experience how we run the senior capstone design competition, because I read also some website, I read also some news about this competition. Is it possible for you to explain for us what kind of the competition should be done in Indonesian perspective, I think?
So normally when we had the physical event, so normally senior design student, they will bring a poster. So then we bring the industry people, they evaluate their posters. And if we cannot do the poster, then they present their PowerPoint. And based on their PowerPoint, then industry judges, they'll be asking question, how good is this? So then that's the, if we do like virtually, they'll be giving maybe 10, 15 minutes, each team will present, and then we'll evaluate their senior design project, and we make the selection. First, second, third place winner. That's the way we do. But mostly we do the poster competition. Now we know the global pandemic situation. We don't do any more event physically right now for time being. And that's the should be like, if they have the poster, if they don't have the poster, they'll get PowerPoint presentation, and then we can come up with more details how we can conduct those kind of things. But we are doing quite some time. Sometimes we have more participants, sometimes we have less participants for senior design project.
Okay, thank you.
When we had in Dubai, we got a lot of local participants. They brought their posters and they presented in 2015, and same thing. And if we do, like, we'll be coming back in Indonesia. But we'll have our Asia Pacific conference in Indonesia first, led by the Dr. Sutupu. So then I think we can do that time. Hopefully pandemic would be over. That time we can do Asia Pacific region, capstone design, or the senior final year project design competition that time. Is Dr. Sutupu here? Or maybe he's left. Okay. Yeah, those are great questions. Thank you.
Thank you, Prof. Ali. Thank you, Prof.
Professor.
Thank you.
Any other question? You can ask question directly or write in the chat.
Okay, thank you so much from Mr. Fitra Lestari for the question, and for Professor Hadali and Professor Donald M. Raymer for the amazing answer. So if you have a question, you can write it in the chat box, or you can ask via open mic by raise hand.
We like to hear from students. Some of the students, you should ask questions. Any question you can ask. Don't feel shy that to ask the question, any question. Don't worry, my question would be good or not, it doesn't matter. And if you cannot, you can type it. Just type it and put in the Zoom chat box. Just type your question, then the MC that Aldria, right? How do you call Aldria? Your name?
Elsa Aldira, sir.
Okay, Lisa Aldria. Okay.
Miss Elsa?
Yeah.
Yeah. Yeah, I have some question to Prof. Ahad Ali and Prof. Dan Wima. Yeah. Actually, in our new curriculum, we add capstone design as a new course. Yeah. So we have not only senior project, but also capstone design course. In capstone design course, we have some students make some group for solving problem that they can find in the real world. Yeah, and then they 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 propose some alternative solution, and they will choose the best solution for the problem. So maybe you have any suggestion related to this? I mean, without I mean, to compromise what they have achieved in the capstone design course to their final project. Yeah. Okay, thank you.
Okay, my suggestion would be, remember that I presented one senior design project. They are doing the car folder, automotive car folder. So it could be like a student would come up with the design idea and they do the prototype using the digital 3D printing or the digital manufacturing, any other techniques. So they have their prototype and then they can compare and they can come up with the cost, how is the business case, those kind of things. So that would be part of the, so you can, it would be like more product related or software related. If they come propose something, so they have to develop a software, like, and then they have to show the software. Or if they have the simulation, they have to show the simulation. So they should have some product, either soft product or the real product, a real prototype product, and then compare. So then you can limit it to this kind of a design related one. And the final year project would be more broader. You can say the synthesis project, they apply a lot of things to come up with the real life solutions. So that's why you can separate both. But sometimes they might do little bit in the design project, part of the senior design project, but that would be more in depth, more details in the final year project. But the capstone, you can try to find that's more on the product development time. So focus on more product development or software development or solution development, any kind of solution development, that kind of thing. So not necessarily physical product, like if they come up with some solution simulation packages, new simulation packages they are doing to, they can develop into the C++ or the programming, MATLAB, and then they come up with the solution. Or even sometimes they can do the Excel and then they come up with the execution, that new way they're solving something. So Professor, do you want to add anything here? How they can make two separate capstone design and final year?
I think the approach of working with industry is always good. The Cintas project was an excellent project because industry welcomed that, and they really needed the work that the students performed. It added significant value. So I think if you can find an industry-based project, that's good. And on the other hand, if you want to really test innovative skills, having students come up with an idea that can result in creation of product or an algorithm, that's also a good approach as well.
And for the Capstone design, they must do the patent search. So that kind of thing, you can put the kind of a requirement. And for the final year project, if they solve the industry problem, if they cannot find local industry, so you can connect with the national, like from the, if they're in Jakarta, they're in Sumatra, they're in other part of the Indonesia, Kalimantan, so they can talk to them, or even global, because they do the logistics, supply chain, other areas. So they can contact with them and then they get the information, and that's why they can solve industry problem for the final year one. So that I recommend, that trying to solve the real life problem for the final year, and then Capstone design will be more focused on the innovative ideas and make the prototype and do the patent search and comparison, that kind of things. And we can discuss more details, maybe just see what your course description outline, then we can give more feedback. If we have the both course outline, then we can see how much overlapping and how much should not be overlapping.
Okay, thank you, Prof. Ahad Ali and Prof. Don. Yeah, thank you.
Yeah, thank you, Professor Hijam. Yeah.
Okay, thank you so much from Mr. Hisham for that question, and for Professor Ahad Ali and Professor Donald Emrimer for that amazing answer. Maybe I will open for the last question. So I will remain you again. If you have a question, you can write it in the chat box, or you can ask via open mic by raise hand first.
What's the, so I'll ask question maybe myself. So Professor Hijam or the other professor or student, what are the major challenges doing a capstone at your place?
Okay, so we have
From
the
the
last
student
question.
perspective.
Okay, so we have the last question from Ian Devi Fitriani. The capstone design
Okay.
is open-end. What project parameters are good to choose for this capstone design? For Professor Ahad Ali or Professor Donald M. Raymer to answer.
Professor Rimmer.
The challenges? Are you
Question
asking
is,
about
yeah, question asked that capstone design is open-ended. What project parameter are good to choose for the capstone design?
I'm trying to understand the question fully.
Did you see in the chat box?
No, I haven't, but I can do that. Yeah. I'm looking at the chat box now.
Okay, I'll let you answer first, then I can add a little bit later. Yeah.
Yeah, the capstone design is an open-ended. What project parameters are good in choosing the okay, well, if you have a group of students that have an interest, something they've experienced in life, or something they really want to investigate, then they're going to maybe have the passion, the dedication, the desire to get excited about it. And there's no substitute for commitment, dedication, passion. That's fine. Sometimes a student or student group cannot come up with an idea. The important thing is to utilize all of their knowledge that's been acquired during from the many courses that they have taken at the in pursuit of their degree. But we found that sometimes it's open-ended and that students will come up with an idea, but sometimes the faculty has to assist or guide them in identifying an idea. The approach that I use in my class is called brainstorming. which basically means that you're looking at a pain causer and a pain reliever. And I could go into that at length, but we just do not have the time. I use this technique to kind of help the students identify a problem or an opportunity. The other thing is, I think that if you have an advisory board within your department, and that advisory board has strong industry participation or representation, you may easily find an industry, a company that would welcome the opportunity to have your students work along and solve a problem that they are experiencing.
And I'll just mention briefly, like, if this is open-ended and it depends, like, are you going to come up with new device for biomedical system or healthcare system? Are you coming up with a solution for logistics? Are you coming up with ergonomics? Or are you coming up with any manufacturing product or the appliances product? And the parameter would be based on understanding the problem. If you understand the problem, and then those parameters would be coming from there. So what are the major things happening that the pain is strong? If there are many accidents happening due to something, so you may say, oh, maybe that's a good problem to solve. Or there are issues that if we can make it better, like you have the ergonomic chair or table or the different. So you have to see there is some great concern going on, like the battery problem, or Boeing, you can see 737 having some problem, and then some automotive having some problem. So based on those, will give you some good clue that how you can come up with a new product, and then there will be a market. So that kind of thing, you have to see what's the impact, what the recent accident, recent thing going on, and that could help you out to identify the problem. So just randomly don't do it. Just try to find some logics, some reasons that the reason you are doing it. So that will help for the company or help for the humanity.
Okay, thank you so much for Ms. Ian for that question, and for Professor Ahadali and Professor Donald M. Raymer for that amazing answer. Okay, so Q&A session is over. Thank you so much for all participants for your participation. Also for Professor Ahadali and Professor Donald M. Raymer for that amazing presentation and answer. I hope the answer and presentation from Professor Ahadali and Professor Donald M. Raymer can help us to add further insights. Okay, so I have a conclusion from Professor Ahadali and Professor Donald M. Raymer's presentation. So, as we know that to make a capstone design project examples, we must have a line balancing, productivity improvement, quality, energy efficient optimization, and new runway scheduling and planning. Capstone design project must pay attention about the final product, typically when working prototype, simulation and the result, hardware and software details, test plans and test results, analysis, design, and cost analysis. Okay, because the session is over, I'm Elsa Aldira Hafidza as a moderator from this event. From the deepest of my heart, I do apologize if there are any mistakes during this event. Thank you very much for your attention. Okay, I'll give it back to MC. For MC, time is yours.
Okay, great. Thank you, Miss Elsa Aldira Hafidza. I would like to inform to all the participants to fill the percents of IOM webinar session given in the chat box. The certificate will be delivered as soon as possible to you as this webinar sessions, and it might takes time. So we are now at the end of the webinar session, but before we end today's webinar, we want to take any documentation. Thus, all of us may open the camera. Okay. I'd like to screenshot the screen. Okay, 1, 2, 3. Okay. So for the next slide. Um, 1, 2, 3. Okay. Next slide. 1, 2, 3. And the last slide. 1, 2, 3. Okay. On behalf of IOM Society and Plasma University, I would like to thank Mr. Ahad Ali, PhD, and Professor Donald M. Raymer for being our amazing speaker for today. Also to all of you that have been participated in this webinar session. We are really appreciate you being here. We hope you found this information valuable in supporting your future. I am Ilman and goodbye everyone. Assalamualaikum warahmatullahi wabarakatuh.
Okay, thank you so much.
Thank you.
Thank you.
Thank you so much, Prof. Don and Prof. Ali. Yeah.
Thank you.
Yes,
Thank you very much.
thank you. So still, I thank you for the nice visit that time. So hopefully we'll visit again.
Yeah. Hopefully we can meet in Singapore next year.
Singapore will make it virtual because still a lot of things going on. So
Oh yeah. yeah.
And thank you. I think Ria, your nice coordination, nice for great MC. I really appreciate. And then Muhammad Ilman, right?
Yes, right.
Yeah,
Yes,
thank you for coordinating the whole thing.
You're welcome, Mr.
So, Professor Rima, do you want to say any few words?
No, just thank you very much. It's been a pleasure to be here. We look forward to having you participate in other IEOM activities, your chapter participating and participating in some of our upcoming conferences as well. And if we can help your student chapters in any way, we'd be delighted to help and to coordinate. Let us know what's going on in your chapter. We welcome the opportunity to publish those in our IEOM happenings. So with that, we hope that you have an enjoyable weekend. Stay safe, stay well.
And some of your project, please join to our IUM Singapore conference or other conferences in the competition, Capstone Design or Final Design. And if you have any paper, you can or abstract, do some publications with IUM.
Okay. We will offer the student to join the conference.
Yes.
Thank you. Okay, thank you so much for your time and everything. If you have any other activities, maybe it's all. If we still have we need some discussion or some activities, it's okay. But if you have another activities, it doesn't matter if you want to leave this session. Okay.
So, and also thank from the Mapua and the Bulchan University, so they're participating. So I could see from the Mapua some of the participants, and you have from other participants, and yeah, Binance, yeah. And Professor Isham, I can see your publication. You got a very good publication for the international. So I get those email with all your international activities and national activities. And those are really good.
Yeah. As your permission, I wrote I wrote some papers with U.S. co-authors. Yeah.
Oh, okay.
Yeah.
Okay, here 10:07 p.m. So we'll take up. So and then so Professor Rimar and myself we can
Take care. Thank you.
Okay, thank you so much again.
Thank you so much.
Thank
Yeah.
you, Prof.
Thank you so much, Prof.
Thank you very much.
Okay, bye-bye.
Good afternoon.
I know.